Activity number 7, Normal Distribution, Sorting, Discovering the Bell Curve, Observing Effects of Large Sample Sizes. We are Group 7 and the members are Hans Joshua V. Ancuna, John Andrew Coronel, Rian Gomez, Glenn Triunfo, and I, Nadine Teres de Guzman. Introduction. Problem description. By drawing numbered slips repeatedly from a container and recording results, you will simulate a normal distribution and observe the effects of large sample sizes. Objective. See how random sampling approximates normality. Task. Each student draws 10 numbers from a container, combine class data to plot, and compare with a normal distribution.
So now, let's walk through our solution approach step by step. First, we applied random sampling, where each member picked 10 numbers from a container. This method ensures unbiased, randomly distributed values. Next, we combined all data from each of us, resulting in a dataset of 15 numbers. This gives us a larger sample size to work with, which is important when observing distribution trends. After gathering the data, we created a histogram. This allowed us to visualize how frequently the values occurred within specific intervals. For our histogram, we have bins of 20. We then overlaid a normal distribution curve on top of the histogram. This comparison helped us see whether the random drawn numbers started to form the characteristic bell shape of a normal distribution. And to analyze the shape and center of the data, we calculated several statistical measures. First is the mean, or average, which tells us the central value of the dataset. And then the median, which shows the medial value when the numbers are ordered. Then the mode, which indicates the number that appears most often. And finally, the standard deviation, which tells us how spread out the numbers are from the mean. And by calculating this, we could better understand the distribution and confirm whether our sample data approximated normality. So here's our flowchart and pseudocode. So first, we prepare a container with numbered slips from 1 to 100, and each member would draw 10 slips from the container, and then record the numbers drawn by each student. After that, we combine all the recorded numbers into a single dataset, and then plot a histogram to visualize the frequency distribution of the combined data. And lastly, we analyze the histogram and compare it with a normal distribution.
So for example number 1, 5 students each drew 10 random numbers from a container, simulating a random sampling process. You can see each student's results listed here. When we combine all these numbers, we end up with a dataset of 50 values. This combined data is what we use to analyze the distribution and understand key statistical concepts. So 10 random numbers per student and 50 values total. And we set the stage for statistical analysis. Next is we visualize the combined data using a histogram. This shows how frequently different ranges of number appear. The red curve overlaid is a normal distribution which helps us how closely our sample resembles a normal distribution. Although it's not perfect, you can already see bell-shaped curve forming. Looking at the number more closely, we calculated the mean median mode to understand central tendency of data. The sample mean is 47.7 and the standard deviation is about 26.96, showing the spread of the data. One interesting point is how adding more students would smooth out the histogram even more and make it more symmetric. This supports the central limit theorem, which says that more data we collect randomly, the more distribution will resemble a normal curve.
On this slide, it illustrates the initial data collection phase of our exploration into normal distribution. So imagine we have a container filled with a number of slips of paper. So each five students reach and drew 10 numbers at random. So as you can see, it records the numbers of each student selected. So this is a combined set of 50 numbers will be the raw data. So we will use this data in the following steps to investigate if it's allow a normal distribution or a bell curve on the next slide. Okay, so on this slide, this is the histogram so that we can visualize the distribution of the numbers. So as you can see, the x-axis represent ranges of numbers 0 to 10, 10 to 20, and so on. And the y-axis shows the density or how frequently numbers within each range appeared. So the red line represent a theoretical normal distribution curve. So notice how the data, while not perfectly matching the curve, shows a tendency towards the bell-shaped pattern with more numbers clustered around the center. And so for the observation and analysis, so for the central tendency, the mean that we get is 46.48 and the median will be 47. So for the mode, it's no mode apply because all of the value appear only once. For spread, the standard deviation is 26.90 for the sample. For the sample size effect, with only 50 data points, 5 students, so 10 times 10 draws, that's why it is a 50 data points. So the histogram shows some irregularity, but we begin to see a loose clustering around the mean. So if more students participate, the following effects would likely be observed. Next is the histogram will smooth out, reducing the sharp peaks and gaps, and the data distribution will become more symmetric around the mean, and the shape will be more closely resemble rather a bell curve, reinforcing the central limit theorem.
This slide set up the experiment. It described the initial action, each student's drawing 10 numbers from the container. This is the random sampling process that will generate the data for analysis. The table shows the raw data collected from 5 students, each having 18 numbers. Next slide. This is the histogram of example 3, a histogram of combined data from all students. The x-axis represents the range of the numbers, and the y-axis represents the density or the relative frequency of occurrences within each range. A normal distribution curve, the red line, is overlaid on the histogram to visually compare the sample distribution to a theoretical normal distribution. This allows for the visual assessment of how well the random sampling approximates a normal distribution. Next slide. Observation and analysis. Central tendency. It gives the measures of the central tendency for the dataset. The mean average of the numbers is 47.62. The median middle value when the numbers are ordered is 48.0. The mode. The most frequent number is 50. These values indicate the center of the distribution of the sampled number. Spread. This shows the standard deviation, which measures the spread or variability of the data around the mean. The sample standard deviation is approximately 26.10. This tells us how much the numbers typically deviate from the average. Sample size effect. This section explains the relationship between sample size and shape of the distribution. It states that if more students contributed data, the histogram would likely become smoother or more clearly defined bell-shaped curve around the mean. This supports the central limit theorem, which states that the sample size increases, the distributions of the sample means approaches a normal distribution.
Conclusion. Activity goal. Simulate a normal distribution through random sampling. Method. 5 students each drew 10 random numbers. Total of 50. Tools use histogram and normal distribution curve to visualize data. This activity showed how random sampling can lead to a normal distribution, even with small sample sizes. In example 1, the mean was 47.7, median is 49.0, mode is 12, and standard deviation is 26.96, with some central clustering but irregularity. Example 2 had a mean of 46.48, median is 47.0, with no mode, and standard deviation is 26.90, showing a flatter distribution. And example 3 had a mean of 47.62, median of 48.0, mode is 50, and standard deviation is 26.10, producing a histogram closest to a bell curve resembling a normal distribution. And that's all for our presentation. Thank you for watching and listening.